So this question is a mix of trigonometric identities, derivatives, and sketching graphs. So let's look at this. The function f is defined by f of x is equal to cos squared x minus 3 sine squared x for 0 is less than equal to x is less than equal to pi. So we want to find the roots of the equation f of x equals 0. So part A, we want to find f of x is equal to 0, and 0 is equal to cos squared x minus 3 sine squared x. We can simplify this by moving it to the other side. 3 sine squared x equal to cos squared x. And then we can simplify this even more. 3 sine squared x over cos squared x is equal to 1. And finally, let's move that 3 to the other side. So sine squared x over cos squared x is equal to 1 over 3. This might look familiar. This is just tan squared x is equal to 1 over 3. And then we can get rid of this squared by doing the square root of both sides. So tan x is equal to 1 over the square root of 3. If you remember your unit circle, you'll remember that x is equal to pi over 6, or also 5 pi over 6. These will be our two roots for our part A. Awesome. Let's go back to part B. So part B says find f prime of x. So find f prime of x, we need to find the derivative of cos squared x and minus 3 sine squared x. We can do it separately because they're separated by a negative. So this is f prime of x is equal to cos squared x d by dx minus 3 sine squared x d by dx. This is just cos squared x is 2 cos x multiplied by the chain rule, which is negative sine x. The second part is negative 6 sine x multiplied by the chain rule, which is multiplied by cos x. So altogether, our derivative is negative 2 cos x sine x minus 6 sine x cos x. We can combine this, simplify it a bit better to become negative 8 sine x cos x. Okay, so this is our derivative, or f prime of x. Our second part says, hence, find the coordinates of the points on the graph of y is equal to f of x, where f prime of x is equal to 0. So we need to find the roots of f prime of x. In other words, when is sine x is equal to 0, when is cos x is equal to 0, because anything multiplied by 0 is 0. So if you remember our sine graph, 0, pi over 2, pi, 3 pi over 2, and 2 pi, our sine graph looks similar to this, where this is 1, this is negative 1. So this goes up, down, down, up. So something like this is our sine graph. And then our cos is also kind of similar, with pi over 2, pi, 3 pi over 2, and finally 2 pi. Our cos graph will start up here, goes down, and then back up. So it looks something like this. So we need to find where, first, let's look at where sine x is equal to 0. Sine x is equal to 0 in a couple spots. First off, right here, and right here. But we are only worried about 0 to pi. So our two spots for our sine, when sine x is equal to 0, is at 0 and also at pi. How about for our cos graph? Our cos graph is 0 at pi over 2 and 3 pi over 2, but 3 pi over 2 is out of our range, so it's just pi over 2. So the coordinates of the point of y of, so the x values are 0, pi over 2, and pi. Now we need to find the coordinates of it of our original equation. So f of x is equal to cos squared x minus 3 sine squared x. Let's plug in these x values to get our coordinates. So when x is equal to 0, we get cos squared x is 1 minus, so I'll write this, f of 0 is 1 minus 3 sine squared x of 0 is, sine squared x of 0 is just 0. So this would be, our first coordinate will be 0, comma 1. Okay, let's look at our second coordinate, f of pi over 2. Cos squared of pi over 2 minus 3 sine squared of pi over 2. So let's look at cos of pi over 2. That's just 0. So cos squared of pi over 2 will be 0. Minus sine squared of pi over 2, that's 1. So minus 3 times 1, and that's negative 3. So our next point is pi over 2 and negative 3. Our final point would be f of pi, which is cos squared of pi minus 3 sine squared of pi. Okay, so cos squared of pi is negative 1 squared, or just 1, minus 3 sine squared of pi is 0. So sine of pi is 0, so 1 minus 0. In other words, our last one is pi, comma 1. So these are our three coordinates for part B. Awesome. Let me get rid of this for some space. Our last part says, sketch the graph of y equals f of x, clearly showing the coordinates of any points where f prime of x is equal to 0 and any points where the graph meets the coordinate axis. part C. We will draw our graph over here. Okay, so our top part will be 1, and the part where it hits the bottom will be -3 because we have our coordinate over here, our maximum. So part 2 over here was our maximums and minimums, where the derivative is equal to 0, or in other words, where it reaches the top and the bottom. So the first point is 0, 1, which is right up here. The next point is pi over 2, -3. So we'll put pi over 2 right over here, and pi over here. So pi over 2, -3 is right over here. And our last point, pi, 1, is back up here. We also know the roots, which we figured out in our first part over here. So x is, or y is 0 when x is pi over 6. So I'll put pi over 6 right over here. X is also 0 when, y is also 0 when x is 5 pi over 6. So right over here. These are our roots. And now we can sketch our equation following the maximums and the minimums and the intercepts. So this is the graph of our equation right here. Awesome job.